Lithuanian? Raise your hand if you're Lithuanian. What? They have no Lithuanians like in this class? That's usually a rare thing. The reason usually I do have a few. The reason I say that, this is a shirt about Lithuania. Anyone ever hear the Dream Team, which had Michael Jordan? Michael Jordan over in my corner here. Magic Johnson, and it was the first time that the pros got to play in the Olympics for basketball in 1992. And it's considered one of the greatest teams ever to be assembled. Of course, people will argue after this with LeBron and all that crap, which they're all wrong. 92 is the best team. Anyway, the team that took the bronze that year and actually put up a kind of a fight against this greatest team ever put together was the Lithuanian basketball team. So 92 bronze, and that's what this shirt commemorates. Actually, this shirt is probably about 30 years old, close to. My grandfather had to order them in a magazine online. We didn't have the internet back in the day, at least not like we have it now with all the shopping. Trying to think if the internet was even that big at this time. But the big deal about the Lithuanian team is they used to be underneath the USSR. And in 1988, the Lithuanians were forced to play against their will with the USSR team. So it was the first time this little country got to play basketball as a country, independent from that, and ended up doing very well. So it's like there's actually a movie about this. It's pretty intense about how important it was for the country at that point. So kind of neat. My grandfather always instilled that in me. The idea of that, and my father, very big time. Okay, so that's my tie-dye shirt. I wear it every year on tie-dye day. I guess we won't go over this real quick. Maybe one more time. I'll do like letter B. But we're actually going to hit the quadratic formula quite a bit in the notes and do some tie in some stuff that you should know already how to do. From the graphing last chapter, but review, and then some other connections with that to talk about what the discriminant is. And that sounds like a bad word. Discriminate out in the world is terrible when we're dealing with humans with each other. But actually, discriminant has a similar meaning, but with the math, they're not a bad meaning. Discriminates gives me the type of solutions, and we'll see that as we go further. Real quick and easy extrapolation. I'm going to move in on this one and just kind of go through. How do we have to attack this on Wednesday when we have our little quiz? This will just be solve, right? Well, the first thing is, what do we got to do on the left side? Starts with a D. Everyone, 3, 2, 1, go. Distribute. You got to clean this up. This is not ready to solve yet. You got to do some algebra skills. You probably could have done two things at once. You could have also moved stuff across by adding 10x to both sides. Whatever you do to one side, you do to the other is also a clue for those that are not quite performing the way they should be in this class. Then you need to start writing your steps. You need to start organizing your mind and organizing your work. That is the number one thing that I see with students that are not doing so hot right now. Our work is just not where it needs to be. Our structures, we need to work on it. All right, and that's all you can do. Only you can do it. Can't make you. All right, what multiplies to 7 and adds to 4? There's nothing. All right, so this has to be the quadratic formula. I know you just learned it Friday. Listen to the song over and over again until it knocks in your brain. But that's what you have to go to. If it's not factorable, then it must be the quadratic formula. And this is what x equals, and you have to accept it. Meaning, I can't really show you where it comes from yet. You don't have all the math skills to really understand it. That's not a shot. It's the actual truth. All right, 4 squared is 16 minus 4ac, 1 and 7, all over 2a. Always like that end. Right? And a is 1x squared. So the opposite of b, plus or minus, b squared again, minus 4ac, a is 1, c is 7, all over 2a. Keep it structured. And then just for purposes of speed, this is the square root of negative 12. Now, we better be getting all these things together in our brain. How to simplify that square root of negative 12, in this bigger problem here. Square root of a negative is what kind of number? 3, 2, 1, go. I, so I have an I. And then 12 is 3 times 4. What's the square root of 4, everybody? 2. So it's not hard to break these down. Sure, I wouldn't want you to write this down, but this is what your brain is separating in your head when you're looking at the square root of negative 12. All right, I have a square root of negative, and then 12 is 4 times 3. Square root of 4 is 2. All right, so over explanation probably again. I just have people that are maybe lagging behind a little bit, and we need to get up with everybody else. All right, so square root of negative 1 is an I number, square root of 4 is 2. And that's how that's written there. Okay, now remember this, and I think once you get good with this, you can do this. Everything's divisible by 2. So I'm going to divide every part by 2. What really is happening is you can factor out a 2, or you can split this up into 2 different fractions, whatever you need to do in order to get this to be negative 2 plus or minus 2 over 2 is 1 I root 3. And then actually I don't have a fraction anymore. Okay, never just cancel these two. I get that all the time, negative 4 divided by 2, and I just see people doing that. You will be marked wrong, all right? Because it is wrong. All right, so what I'm going to go through is kind of a connection to what we had last chapter, all right? Graphing this kind of thing, but then we're going to now talk about what we can do this chapter, which is get the x-intercepts. All right, because the x-intercepts come from when y is equal to 0. All right, so that's what we have going on here. So find the vertex of the following quad, then use the quadratic formula to calculate the zeros, which turn into the x-intercepts. Then find 2 more points and sketch the graph. We may not have time for that. I might just do the x-intercepts and the vertex, just for purposes of what's our connection today. And notice our 3 equations as I show all 3. The similarities between them and the similarities between the graphs. But I only have 1 right now. So this is funny. How do I find the vertex? What's the formula to find the vertex? 3, 2, 1, go. Negative b what? Over 2a, which is a portion of the quadratic formula, right? And there is not a coincidence there. I'll show you what the plus minus part does and what that means in terms of the vertex. But for the vertex, this is what you learned. To find it, it's this, which are components of the quadratic formula. There is definitely a relationship there. And then you plug it in. So the opposite of b is 4, all over 2a. Not the same as the quadratic formula song. You do get 1, all right? So I do get a simple 1 there. The opposite of negative 4 is 4 over 2 times 2. Then when you plug in 1, again, this should be all review. And a couple people showed that they did not know this on our last quiz, and I do have a problem with that. When we dealt with it like for a week or more, they kept mentioning over and over and over again, right? So that is an issue. 1 squared is 1 times 2, minus 4, minus 6. I believe we get negative 8 there. So 1 comma negative 8, all the way down there. Now you have the skills to make a connection to last chapter. How can I get the x-intercepts for this if they actually in fact exist? Because I did show you on Friday that when we get I numbers, that is when the graph does. Oh, maybe I didn't. Maybe that is today. So I'll shut up for a second. But we do know, and we should know, that x-intercepts 0 has to be for y. So that's why x-intercepts come from the zeros of the function, or solutions. Solutions to this equation. These are the equations that you had 2 days ago and Friday. You had to solve this when it was equal to 0, or at least get it equal to 0, then solve. So anyway, y 0, what does x become? And then here we go again. I'm going to go ahead and do the quadratic formula, but then we're going to realize something. Like, first of all, if I were solving this 2 days ago, I would have divided by 2, all right, because these are all divisible by 2. And I think this is factorable. Watch what happens with the quadratic formula when you calculate it. Please just do -4 squared and write positive 16. Don't be those -4 squared and then press enter and put -16 here. Unacceptable. Should not be an error that we are making. 2 times 2 times -6. Okay, so we're getting our all over 2a, getting our little review, quadratic formula, what I need to know and what it looks like. And then we're going to make a little extrapolation here later. All right, 2 times 2 is 4. 4 times -6 is -24. Minus a negative, you should maybe do this. Okay, I know this is going to be a positive because I have a negative. Did I do something wrong? -4, not -2. So it's negative b. Oh yeah, it's 4 times. What am I doing? 4 b squared minus 4ac. You're right. I don't know what I'm doing. Okay, but 4 times 2 is 8. Okay, good. That definitely changes things. 8 times 6 is 48, 58, 64. Okay, but going back to that, make sure you know that's a double negative. All right? Maybe that's a good way of doing it in the middle of a question. But we end up with this. Then everybody, what's the square root of 64? 3, 2, 1, go. 8. So this is 4 plus or minus 8. And I guess I'll sneak this down here. Not the square root of 8. I have people double rooting sometimes. I don't get that. The square root of 64 is 8. You put a square root over that 8, I can't help you. I don't know what's going on with that, but it tends to be a thing. I don't know why. All right, but 4 plus 8 is 12. 12 divided by 4 is 3. Now this is how I'm going to write this. I'm going to write this as an x-intercept because I literally did plug in 0 for y. In one of the answers, I got 3 for x. 4 minus 8 is -4 over 4, which is -1 comma 0. And then when I graph these, 1, 2, 3, 1, 2, I'm sorry, that's not correct. I went 3 to the right of 1, 3 comma 0, 1, 2, 3. And I would have known that. My symmetry would have been all screwed up. But look at the symmetry. All right, so now let's just real quick look at the negative b over 2a part, and then this plus minus part. This plus minus part is like the symmetric, how far away the x-intercepts are from the x-coordinates vertex. So there is a little bit of relationship there. You don't have to worry about that. All right, and we're not going to find that third point because, wow, I'm happy with that graph there. Oh, I just missed maybe a little bit. All right, do you see that classic going up parabola? And then we can move on. So 2x squared minus 4x minus 6. All right, there's a reasonable graph from this connecting the quadratic formula and what it actually finds for us in a graph. Next one, okay, because I do want to speed this up. Very close to the same thing, but it says 2x squared minus 4x plus 2. All right, so we're toggling the c value. By the way, what is c? C is the what of the picture. It's the y-intercept. All right, so we can see that we are toggling it. Many people did say that, probably just couldn't hear them. All right, so real quick, negative b over 2a. I think we're going to end up with the same, at least x value of the, quadratic. Sorry, couldn't think of my words there. So the opposite of -4 is 4 over 2a. You still get 1. Plugging in 1 real fast. So really what we're doing these next 3 examples is making an extrapolation of what can happen with parabolas when we look at their vertex and the x-intercept. 1 comma, since I wrote this up, I'll go above here. This is 2 minus 4 plus 2. 1 comma 0. If that truly is the vertex and this goes up, then what is the x-intercept? All right, and the answer to that is it's right there. This is a parabola that's going to go up and it's only going to hit the x-axis once and only once. And we'll prove it. We'll prove it when we try to find the zeros and see what happens with the quadratic formula. And then I could talk about the word discriminant then, which discriminates what kind of solutions we have here. But I'll toggle all three examples back to back here when we actually do that. So to solve for this, the opposite of b plus or minus the square root of b squared minus 4ac, 4, Mr. Samuelis. You screwed that up the last time. All over 2a. All right, so I get 4 plus or minus. Look on the inside. 4 times 2 is 8. 8 times 2 is 16. I end up getting 4 plus or minus the square root of 0 over 4. Everyone, what's the square root of 0? 3, 2, 1, go. 0. Some people are a little scared to answer that question. It is 0. So 4 plus or minus 0, there's no difference. It's just 4. 4 over 4 is 1. All right, so I ended up getting the x-coordinate of the vertex. It's because the vertex is the x-intercept. All right, and you only get one answer for that. Okay, so I guess what I could do is use the y-intercept to get a picture of this. Waiting for the pen to activate. And then I could get a little sketch of that there. But notice, on the inside of the square root, I got nothing. And that means I did not get two x-intercepts, I only have one. All right, and it's the vertex. Then the last one, we increase that by another 2. So it's 2x squared minus 4x plus 4 now. Now I've moved the graph even further up. I think you can have an idea what's going to happen with this particular picture. Same old, opposite of b over 2a. And again, that's because we're trying to have similarities between the three questions, but then what are the differences? You know, what happens here? All right, 2 times 1x or 1 squared plus or minus, oh gosh, now I can do plus and negative. 1 plus 4. So this ends up being 2 minus 4 plus 4. So the vertex is 1 comma 2. And I probably should be doing a chart, you know, with values, but we're just trying to make an extrapolation here. We already see that I have 1 comma 2. And if we were going to do this like real fast, the y-intercept is here and then flip across over there. This is going up. Y-intercept 0 comma 4. So I can already see what's going to happen with this. We are not going to be crossing the x-axis. So then what could possibly be the x-intercepts? Well, let's go ahead and do the quadratic formula. Plugging 0 in for this. Minus 4x plus 4. And then I'll go ahead and plug it in up here. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right. And hopefully you see 4 times 4 is 16. 16 times 2 is 32. Here's the first time that we had square root of a negative. And that is the extrapolation. That is what you need to know about what happens. By the way, what's the square root of 16, everybody? 3, 2, 1, go. 4. So it's 4i. Good. Someone said 4i. You actually did the square root of negative 16. And then everything's divisible by 4, so that's what will happen. And then you should say, huh? How are those x-intercepts? Someone did it. Good, thank you. How are those x-intercepts? And that's the point. When you get an I number solution, that is exactly what occurs. The graph is a parabola that never crosses the x-axis. And that's what you got to lock in your brain. All right? That is it. And I guess there's nothing else to be said about it. Either memorize that or you don't. Okay, so let's go back and look at all three of these and then talk about what the discriminant is. And what it is what happens on the inside. Look at this one. On the inside, not only did I get a positive number, I got a perfect square. And my x-intercepts, my face is in the way. Let me move this up. The x-intercepts ended up not only being two numbers, But because it was a nice perfect square, it means that was factorable. So I ended up with two integers, actually, or two what's called rational numbers. You'll see, though, that this doesn't always have to be a perfect square, but as long as it's positive on the inside, that square root, you will definitely have two x-intercepts. If this was like the square root of 13 or whatever, then we just get two decimals, and decimals exist on the x-axis, okay? So it'd be two decimal x-intercepts, not a big deal. Notice when the discriminant, I'm going to go ahead and use the word because it discriminates what kind of solutions I have for or x-intercepts. When that's equal to 0, I have one unique 0. It's the vertex. All right, and then when the discriminant is negative, that means the graph never crosses the x-axis. All right, it's either going up and the vertex is above, or it could be below. The vertex is below the x-axis and going down. All right, those are two cases where you get I numbers. So that's that discussion there. Now I want you to write this physically down. Examine the work you did with the quadratic formula for each function. What portion of the formula indicates the number of real zeros? And how do you know? Well, it's this one, and that's what this is called. It's called the discriminant. It's just the b squared minus 4ac, that little part of the quadratic formula. And then we're going to break this down, what we already said, in a nice condensed way. And how do I know? It's because what happens underneath the square root. You know, square root of 0 is just 0. So you don't get any unique two different solutions. Square root of a positive, well then I'm going to get two x-intercepts. Square root of a negative, that's an I number, and we saw the extrapolation in one question. It ended up being a parabola going up that is above the x-axis, no x-intercepts. And we're just going to have to lock that in. All right, so because this portion of the formula discriminates the number of solutions or zeros or roots, not only the number, the type, I really should put that, number or type. And actually, I think type is better than. Because when we say solutions and zeros, we will get those I numbers. But then when we ask for the x-intercepts off of that, there are none when it's an I number. So that's a difference between solutions and zeros compared to x-intercepts as well. So it discriminates the type of zeros or roots. So therefore, they call that little part the discriminants. All right, and that's what we need to know. So just separate what that thing does. It just tells us what's going on behind the scenes, maybe graphically, when we look at that. Okay, love this breakdown. And the type of solutions based off of the discriminant. This is example 1. This is exactly what happened in example 1. The part underneath the square root ended up being 16, remember? And what's the square root of 16, everybody? Say it. 4. All right, so we got square root of, I'm sorry, it was 64. My bad, I made a mistake on the first time. Sorry, that's why we're kind of stunned on there. I don't know where that came from. Actually, it was 64. And 64 is greater than 0. That's what we're saying. If I just look at that part, then I will see that I have two x-intercepts. And the sketch of that graph was this one. I think I had -1 and 3 as a 0. Just proving the point that I have two real, and in our specific example, it was rational zeros. And when that happened, I'm sorry, it should be in this, all of this. All right, but really what we should put at the end is that means we have two x-intercepts. Okay, so type of solutions were real, rational. So number of solutions, there are definitely two, but they are real, all right? And that's what ended up happening. In example 2, this is exactly what happened. I cannot rewrite this. In example 2, the b squared minus 4ac ended up being 0. All right, in that case, we had the vertex was right on the x-axis, and there was only one x-intercept. I don't know why I keep forgetting the I there. All right, number of solutions. That was only one real solution. Well, let's just put one and then put it's still real here. And it actually ended up being a nice whole number. I think it was one again, but or rational or integer would be fine as well. And then when we had this was example 3, where the discriminant ended up being negative 16. Penn's doing a lot of fun stuff there. So we ended up with a negative 16 underneath the discriminant. That's a number that is less than 0. What we ended up with was 2 imaginary solutions, and there were 0 x-intercepts. Got the I in this time. Maybe I should do a erase. That'll let you catch up too. So 0 x-intercepts in that case. Oh, get your little picture. It could be this as well, but I want it to look like what we had for our example there, which is like this. But you could also have a parabola that's below the x-axis and goes down. So that'd be another way that you'd have no x-intercept as well. This is what would happen with the discriminant. Okay, so not too much more. I'm going to tell you what you need to do in your homework today. I pull it out of the book that doesn't exist for you by hand, but you are going to be asked to solve. So you're going to be asked to do the whole quadratic formula to get what x equals. But then you're also going to be asked to discriminate, and you've got to read the directions and follow those and do those 2 different things. So in those questions, you kind of want to break this down like this. So look at what it says. Find the value of the discriminant. Doesn't say solve. Doesn't say get what are the solutions. I don't think there's any graphing today. There might be some graphing extrapolation in the homework. It's all about either solving fully or tell me what the discriminant is. One or the other. So that's letter A. State the number of real or imaginary solutions. If they are real, then determine if they are rational or irrational. They probably should have done this better up here. So maybe in this column right here, we could do 2 distinctions. If it's a perfect square, then the zeros are rational. That means they'll be nice numbers. They'll be like, you get perfect square root of 64, you got 8, and then your 2 zeros ended up being 3 and -1. They could be fractions as well, but those are nice numbers. Or non-perfect square. Then they'll be irrational because you will have the square root of a non-perfect square, and you'll have to break out the numbers and simplify it like our bell work. All right, looking at our bell work could be a good thing to do on this. So let's look at our bell work. Look on the inside. Well, actually, that was a bad example because it ended up being an I number. Darn it, right? But this would be a situation where I have no x-intercepts. But also, if this was square root of positive 12, then we know we'd have an irrational 0. We'd have to get the decimals to find out what the x-intercepts are. So we'd have to calculate on our calculator. Okay, so type of solutions, and then if they are real, are they rational or irrational? So we're not solving. We're just doing this. We're doing what is the b squared minus 4ac part. And then we calculate that number. This number without the square root over its head is called the discriminant. 4 times 2 is 8. 8 times 2 is 16. And we do have minus a negative. So 144 plus 16 is 160. All right, again, get that this is plus right here when I have a negative out there and a negative part on the inside. Okay, first of all, that is positive. So I do have 2 real solutions. That means I have 2 x-intercepts. Since it's real, forgot that I again. I don't know what's going on with my brain forgetting that I. but two x-intercepts will occur. But in this case, the square root of 160 is not a perfect square, so they will be irrational. Wish I could pull an example where we had like 2 days ago. I guess I could. Quadratic formula. I think the last ones I ended up with a what the heck is going on here? Was this it? How come these are blank? Let's see where we had some work done here. Okay, like this one in the bell work here. But let's see where I got ones where I had to calculate the decimal. That's what I was going to do. Didn't we do decimal work on Friday? Yes, no? What? Son of a nutcracker. That's awful. I thought I had that somewhere. Maybe we did it in the square root section. That's embarrassing. Oh well, I was trying to find one where we actually calculated the decimal there. So back to this, you will have decimal x-intercepts. They will be decimals, and you'd have to calculate them on your calculator in order to find out where they're located. I don't know where 1 plus or minus root 5 over 2 is. That doesn't make sense to me. I'd have to go 1 plus root 5 divided by 2, press enter, and then get that decimal x-intercept. Right? So probably overkilling that a little too much. Not a big deal. Same thing, but then I shoved this little question here, so I got to move that off to the side here. We'll take care of it. 2x squared plus 12x plus 20. So 12 squared, b squared minus 4ac. Oh, and then this is going to be a huge number here on the right side of that minus sign. 4 times 2 is 8. 8 times 20 is 160. Is that right? And then this is 144 minus 160. Now notice what you don't have to do. You don't have to do any calculations further from this. You don't have to square root this. No, you just need to know that this is the part, this is what the discriminant equals. So that satisfies letter A. That means we have two imaginary solutions. And then it said if it's, letter C was if it was real, is it rational or irrational? It doesn't matter at this point. But I do want you to know that means there's no x-intercepts. That's what we need to understand why this is important. Forgot that I again. Something's going on in my brain where I just keep forgetting that. So in that section, when they want what is the discriminant, what type of solutions there are, this is what you need to do and nothing further. Now, I did do this. This is part of your homework, and this is how I'm going to end the video. I pulled one of your homework assignments out because it's just worded a little different, and sometimes people don't make the connections. It's really a question that we should be able to do if we just put 2 and 2 together. But I'll go ahead and put 2 and 2 together for you. Find the value of k that will cause the equation to have the given number and type of solutions. So k is missing here. By the way, what is K? A, B, or C? 3, 2, 1, go. It's B. All right, so really it's just a formula fun. But then it says, I need this to only have one real solution. So how would that happen? Well, again, it's the discriminant. And the discriminant makes the type of solutions that happen. Obviously, be b squared minus 4ac. And to have one real solution, the discriminant had to equal 0. It goes back to my 3 columns, the 3 things that can happen with the discriminant, kind of for when you get real solutions, the types that they are. All right, but anyway, for one real solution, the discriminant had to equal 0. Right, that was our example 2, if you want to look at it. But the problem is I don't know what k is. So k goes in for B. I do know what A and C are. So to finish my thoughts there. All right. 5 times 5 is 25. Luckily, 4 times 25 is a hundo. All right. So this is k squared minus 100. Now you have 2 ways that you can solve this. Either through the glory and power of factoring, or from 2 or 3 lessons ago that this is solving by square rooting because I have no middle term. I can add 100 to both sides and then square root both sides. For the love of dog, what is k equal to? Do not make this mistake. 3, 2, 1, go. 10. Everyone said it. I want to jump out the window. You're all wrong, every one of you. Because what is it, 10? What should be in front of it? K equals, say it? Plus minus. You forgot when you square root both sides, you got to put a plus minus in front of that answer. So there's two possibilities. K could equal 10 or K could equal negative 10, all right, according to how this question is worded. So it's definitely a plus minus and both would work. Quick question before we end the lovely, exciting movie.
So even though it says one real solution,
That has nothing to do with it. What this means is I have two different polynomials that will have one real solution. This one will have one real solution, and this one will have one real solution. The connection you tried to make there is not a connection. You know what I'm saying? Those two separate quadratics will have one real solution, all right? And that's what's going on there. That's what you found. That's the answer that you got there. Okay. Good enough. And then for you guys are lucky because I get to see a little bit tomorrow, and I don't know if we could just discuss something, and hey, we have a quiz tomorrow. Second hour, I don't even get to see. So they're done. All right, they are going to see this. I won't see them tomorrow, and they're taking the quiz on Wednesday. So just make sure you understand you got a little bit more than they do. Blah, blah, blah. On the quiz, as I verbalize what's going on with that, it's going to be, you're going to have to factor, and you are going to have to do the square root property. So I'm going to tell that to my second hour, re-look at some of your homework, and look at those methods. That's part of studying. You always have to have like a robotic. Here's what the quiz is going to be. I'll give you a mirrored thing there. It's not the way it worked back in the day.